All right, Math 2, here we go. We've got 8-2, the properties of exponents. Our question today is how can you tell the difference between multiplying with exponents and a power of a power? Because these two get mixed up all the time. And to kind of show what the difference is, we're going to expand each of these to show what's actually happening. Now, multiplying with exponents is what we did in the last lesson. We said that this is like saying, okay, if it's m to the third, there are 1, 2, 3 m's. And if it's m to the fifth, there's 5 other m's. 1, 2, 3, 4, 5. So how many m's do we have? Well, we're multiplying a total of 8 m's. So that means we're adding the exponents. So that's m to the 8th power. This one is not m to the 8th power. And it's easier to see why it's not when we expand it. M to the third raised to the fifth, we call this a power of a power, means m to the third times 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 m to the third. So how many m's do I have here? Well, I've got 3, 6, 9, 12, 15. I've got a total of 15 m's here. So what's happening is I am multiplying the exponents, and I get m to the 15th power. Now, how are you going to tell the difference between these two? Well, I notice when I'm multiplying with exponents, I have bases with both of the exponents. The 3 has a base of m, and the 5 has a base of m. But over here, the 3 has a base of m, but 5 does not have a base of m. So that's really the big hint what we're doing. Parentheses alone, a lot of people go, oh, just look for parentheses. Well, you can show multiplication with parentheses, so that's not necessarily how you do it. What you're looking for is when you're taking a power and that power has no base associated with it. So this 5 is not attached to this m over here. The 3 is, but not the 5 there. So when it's a power to a power, that's when you multiply. When you're multiplying and you've got bases on both of them, then you add the exponents. So here we go. Power of a power, we're going to multiply the exponents. So over here, I've got x is my base to the third. There's no base with the 7. So this means I'm going to do x to the 3 raised to the 7. So 3 times 7. So this would be x to the 21st. Can we have fractional exponents? You better believe we can. We're going to do a lot of those later on. So we're just going to do this just like we've done everything else. This would be 2/3 times 9 over 1. And remember, when you're multiplying with fractions, you can just multiply going straight across. So this would be x to the 18, because 2 times 9 over 3 times 1, 3. And 18 over 3 reduces to x to the 6th power. Last one. Now on this one, we've got a negative exponent that this is being raised to. Now remember what the negative exponent means. Negative exponent means it belongs in the denominator. So we can do it all at once or separate. I'll just kind of do it separate on this one, I think. So this would be x to the 1 times negative 3, y to the 6 times negative 3, and z to the negative 2 times negative 3. So all 3 of these bases get raised to the third power, to the negative third power actually. So this leaves me with x to the negative third, y to the negative 18, and z to the positive 6. Now, since we have in our final answer negative exponents, we need to move these 2 down to the denominator. So my final answer is going to be z to the 6th in the numerator and x to the 3rd, y to the 18th in the denominator. All right, what happens when we have coefficients? Well, when you have a coefficient, just like our last lesson, the coefficients always behave normally. There's nothing different about those. So in this one, I'm going to take 2 to the 4th power. That's 2 times 2 times 2 times 2. which is 16? I think so. So that'd be 16, and then x to the 5 times 4. So that coefficient just behaves normally, and then I do a power to a power with this one. So this would be 16 x to the 20th. Over here, we've got multiplication and we've got an exponent. We need to do the order of operations, which says that exponents comes before multiplication here. So the 3x to the second, we're not going to do anything with that yet. We take the 2 to the third power, so 2 times 2 times 2, that's 8. And then we do a power to a power, so that's x to the 9th. And now we're going to do our multiplication. 3 times 8 is 24. And then we do x to the 2 plus 9, because it's not a power to a power anymore, because they both have bases of x. So this would be x to the 2 plus 9. So our final answer is 24 x to the 11th. All right, down here. So on this one, I'm going to take 4. Now 4 to the second is 16, but it's negative. That means, let's first do this, 10x isn't going to change. What that means is the 16 belongs in the denominator. 4 to the negative second means 16 in the denominator, because 4 to the second is 16, but the negative says move it down there. And then over here, y to the 3 times negative 2, that's y to the negative 6, which means y to the 6 belongs in the denominator. Nothing was left in the numerator, so I'm just going to put a 1 up there. All right, now I'm going to multiply, but when we have fractions like this, we multiply going straight across. So 10x times 1 is 10x, and 16y to the 6 times 1 is 16y to the 6th. All right, we're not done here because the fractions do reduce each other. So 2 goes into 10 5 times, and 2 goes into 16 8 times. So my final answer is going to be 5x over 8y to the 6th. All right, last problem, my people. Here we go. Now, if you have inside your parentheses some reducing that can be done, I would suggest you do that first. Now, sometimes we can do something really quick here. We can say, okay, there's 4 x's on top, there's 7 x's on the bottom. That means after I reduce them, there's only going to be 3 x's left on the bottom. So you can do it like that too. Or I could have just done 4 minus 7 is negative 3. So that means that there's going to be x to the third left in the denominator. All right, so now we can take all of these and take them to the third power. Because remember, when we have all of this raised to the third, that's like saying that I'm going to do y to the 6 times y to the 6 times y to the 6th, and also 3x to the third times 3x to the third times 3x to the third. So this on the numerator is going to be y to the 6 times 3. In the denominator, we do 3 to the third power, and we do x to the 3 times 3, because this is a power to a power. So what am I left with? I got y to the 18th in the numerator. I've got 3 times 3 times 3 is 27. And then x to the 3 times 3 is x to the 9th. And there's our final answer. That's all I got for you. Make sure to answer this question, which we kind of answered right here, but just put it into your own words as your summary for the notes. That's all I got for you today. Math hard. See you later. Bye.